Hi folks, I'm Bill Vales. I'm here today with Tony DeAngelis for another edition of Littleton Rocks. Tony is a lifelong student of geology, minerals, rocks, paleontology, and a variety of other subjects. Welcome, Tony.
Thank you. You know of my interest in all this stuff, so I enjoy it.
That's great. I can't thank you enough for letting us invade your space and take advantage of your deep knowledge and collection of artifacts and things. After the last few shows Tony and I did for Littleton Rocks, we felt it necessary to provide a bit more of a framework for what was occurring in the world during the various time periods of the Earth's history. So Tony and I, we came up with a list of events. I don't know how complete this is.
It's a good overview, though. It really is.
But I think it'll give us a place to start. And some of the items on our list are relative time. We're going to give you folks a framework of the relative time periods that we're talking about. Plate tectonics, which is really the driving force of so much of the Earth's environment.
Well, it is, because that deals with the formation of the continents, so any life on that's not marine would be affected by that.
Okay. And then we're going to talk about volcanism, climate in general, atmospheric conditions, which maybe you could say a few things about what that is, atmospheric conditions.
The atmosphere, of course, early on was devoid of oxygen. And then later, once we had the vast amounts of blue-green algae, they contributed a lot to to oxygenating the planet. So the air breathers were able to, ascend.
Mm-hmm. So the atmosphere has changed throughout time
Dramatically.
And then there's extraterrestrial events that have occurred that have.
Oh, definitely, and that. From the earliest, which were the what they call the early heavy bombardments of asteroids and meteors striking the Earth way back in the Precambrian, all the way up to say relatively recent 65 million years ago, where they think an asteroid spelled the end of the dinosaur era.
Mm-hmm. Relatively recent, 65 million years ago. So. Let's just make mention, what sort of time span are we talking?
Okay, when you're talking about this type of thing, you sort of have to set limits, but if you go back, the origin of the Earth is considered 4.6 billion years ago.
Okay, 4.6 billion years ago.
When we go through it, up until 540 million, from 4.6 to 540 million, that's all considered Precambrian, regardless of the various connotations. It's Precambrian time. If there was life, it was extremely primitive, very little, hard to define. After that, the Cambrian Explosion, as we mentioned in one of our talks, is when life really proliferated. At that point, that going forward, that's only slightly under 12% of the total time. 88% is that Precambrian period, so it's like a long dark spell. Yeah. And then in the last 12%, say, of the Earth's history is when life started to really take hold and come into its own.
And that last period of time from the Cambrian up is roughly 543 million years ago,
right,
to present day. Okay. So we're talking about a vast expanse of time. So it is difficult to wrap our heads around this in conversation.
Yes, very much so.
I know we we spend hours talking about this, and it's always challenging,
Yes.
but it's always fun. So we feel that this list will provide some valuable context to understanding some of the key dynamics that have shaped the Earth in the past and continue to shape the Earth to this day. These events contribute to major extinction events, which there's been how many major extinction events?
5 major ones that they consider.
5 major extinction events, which we'll be talking about, and evolution of Earth, evolution of life on Earth in general. These events contribute to.
Right. As one died off, another species had the opportunity to become dominant.
Yes.
And as I mentioned to you, and I'll do it just briefly, when I was very young, there was a poster or a thing similar to this, a time scale, and they made a big point of connotating everything as the age of, the Cambrian, the age of invertebrates, and then the Silurian, the age of trilobites and crinoids, and then at the end of the Silurian was the age of fishes, and then you go up further and further, when you get into the Triassic, well, you have the Cretaceous, which was the Coal Age, then you go up...
The Carboniferous.
Carboniferous, excuse me, yes. Carboniferous, the Coal Age, and then going beyond that, you get to the Triassic, the age of amphibians, and they transferred later to the Jurassic and Cretaceous, the age of reptiles. And then when that was over, and you get to the Cenozoic, that's when you started with the age of mammals.
Yeah. So the that allows you to associate time frame with something
that you can
tangible.
relate to, right?
You can relate that, and that'll be valuable when we're talking about relative time. But before we go any further with these other topics, we need to talk about plate tectonics because this is really a driving force, and plate tectonics is relatively new. At least the understanding of
the
plate
study
tectonics.
of it, yes. But I mean, and now there's a lot of good references that show the different, as the continents evolved. Don't forget, you had smaller or larger poles, so sea level was going up and down like a yo-yo. And then you had the continents, some of them coming together, forming the giant supercontinents, and then because of seafloor spreading and other tectonic forces, drifting apart, as you well know.
So we have this idea where we have the continents on the globe,
right?
Okay, that are on the Earth, and these continents are actually in motion.
Yes, they are.
Okay, that if we look at the Earth is layered, has various layers with names such as the lithosphere, which is where the
crust,
continent, the upper crust,
right?
And then under the lithosphere we have the asthenosphere, which is the upper part of the mantle, and I've always think of that a little like molasses.
Yes, they call it plastic, or more like Play-Doh even,
Yes.
Not runny as we would consider, lava coming out of a volcano, but still it has a lot of give and such.
Right. And on the asthenosphere, the continents tend to move.
Yes, that's where they move. They're driven by whatever forces that are taking place.
Yeah.
And all the different parts of it. I mean, the obvious one is seafloor spreading, and that you have a rift or whatever in the ocean floor where new crust is being formed as lava comes out, but the continents start spreading apart.
Yeah, and this is the time to use our
books.
Our well-formed props. We have 2 books on geology here, which are going to be our props.
That's right,
for plate tectonics.
Yeah.
And interesting things happen at the edges of plates. That's where the action is.
That's right, and
Okay.
that can be.
And I think the Earth today is made up of roughly 6 major plates, is it? 6 to 9 major
yeah,
plates?
depending on where the Australian one and the other one.
So we have the North American
Right.
plate,
The
South
African
American,
plate, yeah.
African, Eurasian
Yes.
plate, Australian plate. And we have some good diagrams that the audience will see.
Right.
But interesting things happen at the edges of these plates. And as you were just talking about seafloor spreading,
Right.
yeah, that's hard to say,
Yeah,
seafloor spreading, one of the places that happens is right under Iceland.
It starts under there and goes all the way down.
All the way down.
Yeah, the Mid-Atlantic
Okay.
Ridge was formed with that
And that means we have 2 plates that are actually spreading apart.
divergence, right?
Okay, they're spreading apart. And so as magma comes up from underneath, it forces these plates apart.
Right.
And effectively, Europe is getting further away from Boston
That's true, yes.
every year. And that's actually a measurable
Oh, it is,
amount
yes.
of, I think it's on the order of a centimeter or 2 a year.
Okay, I wasn't sure what the amount was because various ones have different amounts, but that sounds like it's very probable.
And it's measurable, and because people do dive in pressurized submarines down
now
down
they
to these
can,
ridges
yes.
and check out the new Earth being made.
Right, and they also send robotic craft down there to check on them.
So we have plates spreading. Okay. Now, what's another dynamic?
Well,
What
another
else
one,
do plates do?
plates collide, and when you have that happening, you have the 2 plates coming together. And a lot of times you will have a subduction zone, which means one is when they collide, one goes under the other. That often the upper one is contributing to mountain building. Okay, so you will have big, large mountains. I forget what plate was going under the one in Tibet, but caused this huge, the whole Tibetan plateau is way up because of that.
So the plate that subducts or dives under tends to be made of heavier material.
Yes, for the most part,
So it tends
right.
to be ocean
Like
floor,
basalts and stuff,
which
right.
is heavier. So as an ocean plate meets a continental plate, you would get this subduction where the ocean plate is going under.
Yes.
Okay, and as you said, the continental plate would be going up in the air. Now, some interesting things happen where this plate is going under, where the plate is subducting. Okay, so maybe if you hold that piece of ocean crust there. But under here, as this plate is diving down, it's being subjected to heat and pressure. Okay, and at this area, at this boundary, we have some magma that's rising to the surface. Some of it gets to the surface, some doesn't. And it may form volcanoes. We may see volcanoes around here. And we see examples of that all around the west coast of North America, the west coast of South America.
Yeah, right. Down the land of fire, in Indonesia, where all those big volcanoes, because that's another place where you have plate boundaries.
Yeah. So we get this ring of fire.
Right.
That circles the actually the area that we think of as the Pacific Ocean.
Right.
Up to Alaska.
Yeah, and all the way down, right.
And down. So we have these plates that are going like this. Now we have spreading plates, subducting plates.
And then you have the ones that are moving against each other, which are a big problem.
Okay, and that would be like this.
Yeah, like a transverse one, and those are usually, they can, if they go in a very small, slow fashion, that's okay, but a lot of times it doesn't happen. It's like an elastic being stretched more and more, and then finally lets go. When it does, that's when you have your major earthquake.
Yes, yes.
And those can be devastating to our civilization as we understand it.
Yeah, so if a transform plate, as it's moving one plate next to another, if it sticks, let's say if it sticks,
right.
and pressure gets built up,
boom.
and then boom,
yeah, and
it lets go.
Right.
The result is what we call an earthquake.
Yes, exactly.
Yeah. And yes, you're right. That can have devastating effects. Now, you can also get, even on a subducting plate, the plate can stick a little bit there. So you can get the same sort of dynamic where this sticks,
right.
lets go, and you get an earthquake. The action is at the edges of these plates.
It is, and people, when you talk about plates, they have to have it in their mind. We're not talking about something the size of Massachusetts. We're talking about something the size of North America, even though we're not affected all. And then there's localized things where you'll have, faults occurring, overthrust faults and upturned rocks and everything, which plays havoc with the geological records, but it does happen, and that's another part of that.
Yes,
smaller part.
Yeah, and what you mean by an overturn fault is that land, let's say, was pushed like this, and all of a sudden land that was laid down this way has actually turned all the way over.
And from what I understand, the Rock of Gibraltar is an example of that.
You had mentioned that to me, and I did some reading on that, and indeed that's correct.
Yeah,
the Rock of Gibraltar is actually an example.
Yes, and that's no small thing.
Yeah. Now, I was able to find in Littleton a very interesting fold where some metamorphic activity occurred where the rock was actually folded.
Oh, wow.
Like that.
That's very nice.
We'll show that to the audience. Okay, so plate tectonics has been going on
from
day one. But this theory of plate tectonics really took hold around 1966.
Did it? Okay, I thought it went into the late 50s, but it wasn't really developed to any extent, I believe.
Yeah, and when a lot of mapping, when the United States Navy did a lot of mapping of the seafloors, these ridges with the sonar.
Yeah, what year was that when they did the big deep sea survey? Do you know?
I'm not sure of that, but my uncle actually captained a United States Navy destroyer, the USS Whittick, and on the back of that they had a large piece of sonar. It looked like a huge whale, bigger than the house, that was lowered down into the sea, and it was used as part of the mapping, the mapping project. And I remember him doing that in around 1964, 65.
Okay,
so so when the theory of plate tectonics took hold, it answered a lot of questions.
Yes, it really did, because it made sense of what was happening, and also they found a lot of evidence, when they weren't sure of different things, when they took samples, like they take a sample from the North American plate and then from the African plate, and they want to correlate them, and okay, the rocks look similar, blah, 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 but what they did was they found some of the iron-bearing rocks, iron minerals, and they could look at the magnetic fields, and they say, okay, this one is exactly the same as this one, or this one isn't, then they know, new lava and new seafloor was created. That's pretty, pretty amazing.
Yeah. And another amazing thing that we'll only just mention, because this could take hours to talk about, but on these spreading plates where new land is being made, the magma that comes up is aligned according to the poles.
Right.
Okay.
Yep.
And those that alignment tells you where the pole is at the time the magma was made.
Right.
And
because that does move around as well. Right.
Yeah. So over time, when people find parts of different plates, they may find that the alignment is pointing this way, pointing this way, and in some cases even pointing the opposite way, showing the phenomena of pole reversal, that the North Pole is not always the North Pole.
Right.
As we think of it. So that's another very interesting concept. So, okay, so we have plate tectonics, and over time, this has taken our continents, and as we know the continents today, they weren't always positioned in that way. Okay, that there were some times that the continents were all assembled together.
Yep, they all clustered into giant supercontinents.
And when that happens, now you have a larger landmass. Okay, a much larger landmass. And what sort of effects might a large landmass have with respect to climate, let's say?
Well, there's a lot of different things that a larger landmass gives you more sea as well, and that, absorbing radiant energy from the sun, a lot of that will affect the climate in various ways, heating up the Earth somewhat, and it's gone through several different cycles of, and then the supercontinents, once they split up and they start wandering, you have more seafloor spreading and stuff. And I don't know how much you want to get into it, but there were certain things like the Deccan traps and things like that, where they were these just almost a split in the crust and just endless amounts of magma. I mean, covering, what was it in India? 2 million square miles, I think.
Yeah,
incredibly.
The Deccan basalt traps.
Yeah. And then there was one in Siberia as well.
Yeah.
And these covered millions of square miles, so it wasn't like a solitary volcano like in Hawaii just spewing out some magma. These were like, giant splits in the crust where, endless amounts of stuff poured out of the, from the mantle.
Now, when this magma is pouring out from the mantle, there's a lot of gases, in some cases highly volatile gases, and that's certainly going to impact the atmosphere.
Yeah, there was sulfurous gases which contributed to making a very acidic rain of sulfurous and sulfuric acid, so that didn't do too much for things. Beyond that, you had a lot of water was trapped within the magma, as I understand it. So what wasn't contributed by meteorites and asteroids, a lot of it was trapped in the magma and eventually came down as rain and helped make the oceans, what they were.
So here we see plate tectonics. As the plates are coming together, there's a lot of volcanic activity going on with those. With volcanic activity, we get lots of gases being released to the atmosphere, changing the atmosphere. We have continents being rearranged such that animals, depending on what time in the Earth's history this happened, but when continents are together, animals can cross from one area to another. But when the continents are separate, they can't.
Right, and that's a good point because that leads us to index fossils. And if you look at, say, when North America and Africa, say, were together or whatever, you'll find animals here, in this section. And now they've spread apart, but you'll find the index fossil here and here, showing that, one time they were likely together. Mm-hmm. So all the evidence stacks up in favor of the theory.
Yes, yes. So this is, plate tectonics really drives a lot of what we talked about. I know in previous shows we provided a lot of really good eye candy, which we're going to get to
Right.
eye candy on different fossils, different types of animal life. But we were really fast and loose about, how'd that animal get over there? How'd
Right.
that animal get there? So we're kind of backing off a little now, talking about plate tectonics. This is some of the dynamics
Yes.
that allows that to happen. Okay.
And there are a lot of graphics online that show, some of the relative stages, as does this poster, the various stages of the continents and how they looked at various time periods.
Yeah, we'll be showing our faces will be covered over
Right.
with numerous graphics
Sure.
during editing that shows some of these concepts. But there are some great YouTube videos that actually animate
Yes.
the process of plate tectonics and give
Yeah,
you that
yeah.
visual of how
Right.
continents actually move and the forms that they take. And this is something that we're going to talk about further. So for this show, I think that's an overview of plate tectonics using our sample
Yes, right.
plates here. Okay, and it was important to, I think, to get that out on the table.
Well, yeah, because again, it drives a lot of, throughout history, there is movement to the continents. That's not going to change, it's not going to stop. And it's important to realize that that was a part of the development, of once life had taken to land, that was responsible for some of it. Or, where was it, New Zealand or someplace that was very isolated and didn't have much contact with the rest of the world, where, there's just some species that are found nowhere else
Yes.
because of that.
Yes.
And I think, that all of that is related to tectonic motions.
Yes, yes. I think Mozambique is another
Oh,
place.
is it? Okay.
I know in other Littleton Rock shows I've talked about how Littleton was actually affected by plate tectonics, where the Clinton-Newbery Fault, which was one of the microcontinents of when Africa collided with Laurentia. It was
okay.
actually Gondwana.
Yeah,
was the
Gondwana,
name.
yeah, right.
Collided with Laurentia.
Right.
It brought part of Littleton over.
Oh, okay.
Okay, and then when the continents spread up, what it left there was part of Littleton, and along with that was part of what we call the Clinton-Newbery Fault, which is in Littleton. But that is for our Littleton audience. The obvious area where we see plate tectonics, or at least might get us wondering, is when you look at South America and you look at Africa. Look at those two continents, the way South
definitely
America
fits in, yeah.
fits in nicely
Yes, very much so.
into Africa. That was something that people pondered for a long time, and plate tectonics provided the
Right,
answer.
and even in today's modern world, people are very aware of the San Andreas Fault in California, and the people that are less informed say it's going to break off and fall into the sea. Well, it's not, but there is motion that's occurring there, and sometimes with the buildup of tectonic forces, it can be devastating,
Yeah,
which is like the 1908 earthquake.
absolutely. Well, at this point, we're gonna call this show a wrap with our
Okay.
introduction of plate tectonics, and we're gonna pick it up in another show talking about time scales and how time fits into the plate tectonic model. But for now, I hope you found this show informative. Tony, thank you very much.
You're very welcome.
Okay, and we'll see you next time.